Okay, today I am explaining about the generator, transformer, unit protection. Okay, this is the combined protection for that both of that generator and the transformers. Okay, in that generator and the transformer protection, we are using the different protective devices for protection of that earth faults and interturn faults and also face-to-face fault and also some leakage of that flux, that all will be protected from using this interconnected generator and the transformer protection. First, in that case, we are using the differential type of protection, that is the generator and the transformer unit bias differential protection. Okay, in a high voltage transmission systems, in a high HV lines, the bus bars are very at high voltages. Okay, then the generators. Okay, in HV systems, the bus bar voltages are very high. Okay, then compared to that generators. Okay, therefore, that generators are directly connected to the step-up transformers. Okay, that generators are directly connected to the step-up transformers. Okay, to which it is connected together from a generator transformer unit. Okay, that is called as the generator transformer unit. Okay, the protection of such a unit is achieved by the differential protection. The overall generator and the transformer is protected by using the differential protection schemes. Okay, the protection of such a unit is achieved by the differential protection scheme using the circulating current principle. Okay, by using this circulating current principle, we give the protections from the generator and the transformers for different faults. Okay, we already discussed the each and every protection for that generator and also the transformer. Now, in this case, we give the protection schemes, various protection schemes for that both of the generator and the transformer unit. Okay, while providing protection to such a unit, it is necessary to consider the phase shift and current transformation in the step-up transformer. Okay, while giving the protection to that generator and the transformer unit, it is necessary to consider the phase shift and the current transformation in the step-up transformer. Okay, we observe that phase shift and also the current transformation in the case of a generator and the transformer unit protection. Okay, in that case, we are using the biased differential protection. Okay, we already discussed about the what is meant by the differential protection and what is meant by the biased differential protection. Okay, that all will be studied in the generator protection and also in the transformer protection also. Okay, same working principle is obtained in the case of that generator transformer unit biased differential protection. Okay, the zone of such a scheme includes the stator winding, okay, the step-up transformer and intervising connections. Okay, this is the basic circuit diagram or basic connection diagram for that generator and the transformer unit. Okay, this is the generator, and this is the transformer. Okay, this is the transformer. In the transformer, this is the stator winding. This is the primary winding and this is the secondary winding. This is the primary winding and this is the secondary winding, and this is the generator. Okay, that generator is coupled to that main transformer. Okay, that generator is coupled to that transformer. In that diagram, we are using the different protective schemes. Okay, at the both ends of this generator and the transformer sets, at the both ends of this generator and the transformer sets, we are connecting the both the CTs. Okay, this is the one side CT star connected, that will be, and this is the another side CT, that is the delta connected. Okay, both that CTs are connected by this restraining and the operating coils. Okay, both that CTs are connected by the restraining and the operating coil. Okay, at the secondary side of this transformer, we are connecting the one earth fault relay. Okay, this is the earth fault protection for that transformer. That earth fault relay is connected at the transformer secondary windings. Okay, that is the differential protection. First of all, under normal operating condition. Normal operating condition, in the basic case, we are using the both the CTs are in the balanced conditions. Suppose under normal operating conditions, the algebraic sum of these currents will be equal to the 0. Then no relay coil will be operated. Okay, suppose if any disturbances or any faults are obtained internally, suppose any faults are obtained internally. Okay, that means the internal faults are obtained in that generator or the transformer or both of that units. Due to that fault current, some disturbances are obtained in between these two cities. Okay, the balanced conditions of these two cities are disturbed when the internal faults are obtained. Okay, the balanced conditions of these two cities are disturbed when the internal faults are obtained. Okay, why? Because that balances are disturbed. That means suppose that internal faults are obtained near the transformer or the generators. In that case, short circuit currents are flowing through that CTs. Okay, due to that flow of that short circuit currents, there is a changes in that balances of that CTs. Okay, therefore we obtain the algebraic sum of these two currents of that CTs. That algebraic currents will be flowing through that some relay coils. Okay, the algebraic sum of that currents is flowing through this relay coil. Okay, therefore that algebraic currents are passing through this coil. Therefore an operating coil will be operated. Then the relay coil will be operated. Okay, that faulted currents is flowing through that relay coil. Due to that restraining coil, when compared to that already fixed currents, that will be compared by that restraining coil. After that, it will be compared to that operating coils. Okay, while comparing this operating coil current to the restraining coil current, there is a some changes will be obtained. Due to that changes, that operating coil is more energetic than that restraining coil. Okay, therefore that operating coil is more energetic, then automatically that relay coil gives the indication to the circuit breaker. Okay, first of all, we are taking the generator and the transformer unit. Okay, this is the generator and this is the transformer. Okay, main power transformer. Okay, this is the primary winding and this is the secondary winding. The primary winding is connected in the delta connection and secondary winding is connected in the star connection. For earth fault protection or earth protections, we are using the one restraining earth fault relay. Okay, this is the circuit diagram for that earth fault protection from the earth faults. Okay, and this is the differential protections at the both ends of this generator and the transformer. We are connecting the two CTs. Okay, this is the star connected CTs and this is the delta connected CTs. Okay, under normal operating condition, that means the no fault conditions. Okay, under normal operating condition, that means the no fault conditions. Okay, no fault condition means the algebraic sum of these currents is equal to the 0. Okay, the algebraic sum of these currents is equal to the 0. Okay, these zero currents will be flowing through the relay coil. Then in that case, the relay does not operated. Okay, then in that case the relay does not operated. Okay, suppose if any internal faults are obtained, or suppose the faults are obtained within this protective zone, then automatically the balance between these two cities are disturbed. Okay, then automatically the balance between these two cities are disturbed. Okay, this is the cities 1, this is the city 2. The balance between these two cities are disturbed. Due to the disturbance of these balanced currents, or the algebraic sum of these currents does not equal to the zero. We are obtaining the some faulted current. Okay, that faulted current is flowing through this restraining coil. Okay, that faulted current is flows through that restraining coil. Okay, suppose that faulted current is flows through the restraining coil. In that restraining coil, we already give the sum of that current, that is the maximum rating of that faulted current. Okay, that current is compared to the algebraic sum of the currents. If that current algebraic sum of the currents will be more than the restraining current, then automatically that current will be flowing through the operating coil. Okay, then automatically the current is flowing through that operating coil. Okay, when the current flowing through this operating coil, in that case the relay will be gives the indication to that circuit breaker. In that case only this the relay will be indicated the circuit breaker. Then automatically the circuit breaker disconnected from the supply for both of the generator and the transformer units. Okay, this is the earth fault. This is the earth resistance. If any earthing currents are flowing to that earthing currents, by adjusting this resistor we adjust that earth fault currents. Okay, that is the main reason for usage of this ground resistance. Okay, this is the both the combination of the generator and the transformer, generator and the transformer protection. Okay, in that we are using the both the generator and the transformers, both the generators and the transformers. Okay, in that case the transformer is delta star. Hence, the current transformer on the high voltage side are delta connected. Okay, the current transformer on HV side is delta connected, while those on generator side are the star connected. Okay, while observing this main transformer, at the generator side we are connecting in the delta connection. At the CT side we are connecting the star connected transformers. Okay, this cancels the displacement between the line currents introduced by the delta connected primary of the transformer. Okay, that is the reason we are connecting the delta and the star connections for the generator side and also the CT side. Okay, therefore for connection of this delta and the star connections, this cancels the displacement between the line currents. Okay, this cancels the displacement between the line currents introduced by the delta connected primary of that transformer. Okay, introduced by the delta connected primary of that transformer. Okay, where there is no fault, suppose if there is no faults, that means the no fault condition, the secondary currents of that current transformer connected on generator side. Okay, no fault condition, that means the secondary currents of the CTs are connected on the generator side are equal to the currents in the pillet wise. Okay, that will be equal to the current in the pillet wires from the secondaries of the delta connected current transformer on the secondary side of that main transformer. Okay, that will be equal to the currents in the pillet wires. Okay, that will be equal to the currents in the pillet wires. Okay, from the secondaries of the delta connected current transformer, and the secondary of the main transformer, and the secondary of that main transformer. Okay, next, when a fault occurs, suppose when a fault occurs, the pillet wires carries the differential current. That means the algebraic sum of the both the CT currents, that is the CT1 and CT2, that is I1 plus I2. Okay, the algebraic sum of these currents does not equal to the 0. Okay, that means the I1 plus I2 current does not equal to the 0. Okay, that does not equal to the 0 means that some currents will be obtained in that case. Okay, that current is flowing through that relay coil. Okay, suppose when a fault occurs, the pillet wires carries the differential current. Okay, that wires carries the differential current to operate the percentage differential relay. Okay, by using that differential current, the percentage differential relay will be operated. Okay, for the protection against the earth faults. Okay, for the protection against the earth faults, an earth fault relay is put in the secondary winding of the main transformer. Okay, this is the secondary winding of that main transformer. This secondary winding is connected to the restricted earth fault relay for the protection of the earth faults from the for the transformer. That's why we are connecting the earth fault relay for the secondary of this power transformer or the main transformer. Okay, for the protection against the earth faults, an earth fault relay is put in the secondary winding of the main step up transformer. Okay, for the protection against the earth faults, an earth fault relay is put in the secondary winding. Okay, that earth fault relay is connected to the secondary winding of that main transformer. Okay, main step up transformer. Okay, in such cases, differential protection acts as a backup protection to the restraining earth fault protection. Okay, within the same time we are checking the differential protection and also the restricted earth fault protection. At the same time, both the relays are operated when the earth faults and also the face-to-face faults or the overloads are obtained. In that case, both of the relays will be operated at the same time also. Okay, in such a cases, differential protection acts as a backup protection to the restricted earth fault protection. Okay, suppose in the if only earth faults are obtained, in that case that differential protection is gives the backup protection for that restricted earth fault protection. Okay, that differential protection gives the backup protection for that restricted earth fault protections. Okay, these overall differential protection schemes do not include the overall differential protection schemes does not include the unit transformer, as a separate differential scheme is provided. Okay, as a separate differential scheme is provided. Okay, first coming to this restricted earth fault protection. In the case of that restricted earth fault protection, we are using the separate connection diagram for that restricted earth fault protection. Okay, in that diagram we are using this restricted earth fault relay. Okay, this is the differential type of protection. Okay, this differential type of protection gives the protection against the against the phase faults or the overloadings and phase to earth faults, that all will be protected by using this differential protection. Okay, that is the biased differential protection for that both the generator and the transformer units. Okay, in that secondary of this transformer, we are connecting the one restricted earth fault relay. Okay, this is the one restricted earth fault relay. Okay, this restricted earth fault relay gives the protection. This restricted earth fault relay gives the protection from that earth faults for both of the transformer and also the generators. Okay, for both of that transformer and also the generators, this type of protection gives the protection against the earth faults, against the earth faults. Okay, this is the basic connection diagram for that generator and the transformer unit. Okay, why? Because we give the combined protection for that generator and that transformer, means the in the we give the protection for that all the face to face fault and face to earth fault, and also the some of the protection for that overloadings and overfluxings, leakage of that flux, that all will be given for that both the generator and the transformer. Okay, by using this same protection scheme for that both the generators and the transformer units, okay, by using this both the protection, by using this type of protection schemes for both the generator and the transformer units, we give the combined protection for that all the faults. Okay, we give the combined protection for that all the faults that will be obtained in the case of a generator and also in the case of a transformer and also in the case of that transformer. Okay, but why we are using that combined protection for that generator and the transformer, means due to that combined protection for that generator and the transformer, we are having the some of the advantages and also the some of the disadvantages are there. Okay, what are the advantages for giving that generated transformer unit protection is the space occupation and also the usage of the protective devices for that generators and the protectors, that all will be reduced. Then the initialization cost for that protective relays and also the maintenance cost also will be reduced while we are using the combined protection for that generator and that transformers. Okay, that's why we are using the generated transformer unit protection. Okay, that is the main reason for combined usage of that generator and the transformer protections. Okay, in the previous classes we already discussed about the what is the protections, what are the different types of faults that will be obtained in the case of a generators and also in the case of a transformers. First of all, we identify the which types of faults are obtained. Due to that faults, what are the effects are to be produced in generators and the transformers, and also which type of protection is given for that type of the faults, that all will be discussed. Okay, but in this topic we give the protection for that overall generators and the transformers. Okay, in previous classes we already discussed about the protections for that earth faults, protection from that leakage of that currents, protection from that interturn faults, and also the protection for that face to face fault and protection for that face to neutral faults. Okay, that all will be discussed in the last classes also. Okay, in present topic, that is the generator and the transformer unit, in that case we are using the combined protection for that all the parts of faults. Okay, combined protection for that of all the faults. Okay, Okay, in HV transmission, in high voltage transmission systems, the bus bars are operated at high voltages than the generators. Okay, this is the HV, sorry, this is the main transformer and this is the generator. Okay, this is the main transformer and this is the generator. Okay, while giving this protection for that both of the generator and the transformers, we are giving the one restricted earth fault relay and also the one differential type of protection, and in that case we are using the alert alarm for that neutral fault conditions for that generator, or the alert we set the alert alarm for that neutral faults of that generator also. Okay, we give the alert alarms when we are obtaining the earth faults in the generators. Okay, that all will be connected in this diagram only. Okay, this is the protected generator and this is the protected transformer. Okay, this generator and the transformers are connected by the combinedly, and that secondary of this transformer is connected to this restricted earth fault relay. Okay, this is the restricted earth fault protection from that transformer, and this is the differential type of protection. Okay, this is the CTs and this is the CTs. Okay, this is the neutral connected relay coil, that is the when any earth faults are obtained from that point, in that case it gives the alarm signal. Otherwise, while adjusting that resistance, then we limit the faulted currents. That is the main reason for the connection of that resistor in the neutral point or the ground point. Okay, this is the generator and the transformer, and this is the generator and this is the main transformer. These two are the protective systems. Okay, these two protective systems are protected from the face to face faults and also the phase to earth faults and also the some interturn faults and also the leakage of flux and also combined protection for that leakage of that combined protection for that leakage windings, that all will be protected by using these differential protections. Okay, that's why first the generator unit is connected to the main transformer, and both the sides of this generator and the main transformer we are connecting the two CTs. Okay, at the both the sides of these two generator and the transformers we are connecting the two CTs, that is this is the CT1 and this is the CT2. Okay, in this case we are using the bias differential protection. Okay, what is the difference between this bias differential protection and the differential protection is that in the case of a differential protection only we are using this differential relay. Okay, we does not use any restraining coils. Okay, why? Because we are using this restraining coils means that suppose very less fault currents are obtained, in that case the differential relay will be operated and disconnected from this generator and the transformer units. Okay, that is the one of the major difficult in the case of a differential protection. Okay, that will be overcome by using this type of bias differential protection. Okay, ఇందులో మనం ఏంటమ్మా జనరేటర్ కి ట్రాన్స్ఫార్మర్ కి రెండిటికి మనం ప్రొటెక్షన్ అనేది ఇవ్వాలి అన్నప్పుడు కంబైన్డ్ గా ఫేస్ టు ఫేస్ ఫాల్ట్స్ కి, అలాగే ఓవర్లోడ్స్ కి, అలాగే ఫేజ్ నుంచి ఎర్త్ ఫాల్ట్స్ కి, ఇంటర్టర్న్ ఫాల్ట్స్ కి, లీకేజ్ ఆఫ్ ఫ్లక్స్ ఫాల్ట్స్ కి, కోర్ బ్యాలెన్స్డ్ ఫాల్ట్స్ అవన్నీ వాటన్నిటికీ మనం ఈ డిఫరెన్షియల్ టైప్ ఆఫ్ ప్రొటెక్షన్ స్కీమ్ అనేది యూజ్ చేసుకుంటున్నాము. ఓకే, దిస్ ఇస్ ద ఆపరేటింగ్ కాయిల్ అండ్ దిస్ ఇస్ ద రీస్ట్రైనింగ్ coil. Okay, both the operating coil and restraining coils are connected at the both the cities. Okay, under normal operating conditions, that means the no faulted conditions, అసలు ఫాల్ట్ అనేది మనకి లేనప్పుడు ఇవి రెండు కరెంట్స్ గాని మనం ఆల్జీబ్రిక్ సమ్ చేస్తే that will be equal to 0. Okay, therefore zero currents will be flowing through that restraining coil. ఓకే, ఆల్రెడీ మనకి రీస్ట్రైనింగ్ కాయిల్ లో కొంత కరెంట్ ఉంటుందమ్మా. ఆ కరెంట్ అనేది మనం ఎప్పుడు చెక్ చేసుకుంటాము అంటే ఏదైనా సమ్ కరెంట్ అనేది ఇందులోకి ఫ్లో అయినప్పుడు మనం చెక్ చేసుకుంటాం. ఓకే, మామూలుగా మనకి ఇక్కడ నో ఫాల్ట్ కండిషన్ లో ఏమైంది, జీరో కరెంట్స్ అనేవి ఫ్లో అవుతున్నాయి. జీరో కరెంట్స్ ఫ్లో అవుతున్నాయి కాబట్టి అసలు చెక్ చేయాల్సిన అవసరం లేదు, రిలే కాయిల్ అనేది మనకి ఆపరేట్ అవ్వదు. సపోజ్ ద ఫాల్ట్స్ విల్ బి అబ్టైన్డ్ ఇంటర్నల్లీ ఆర్ విత్ ఇన్ ద ప్రొటెక్టివ్ జోన్. ఓకే, suppose the fault will be obtained at this point. Okay, if suppose that fault will be obtained at this point, then there is a some disturbances are obtained in that both of that cities. Okay, that means the balanced conditions of these cities are disturbed. Okay, in that case, therefore, while taking that algebraic sum of these two currents, that is the I1 plus I2 current, there is a some differential currents will be obtained. Okay, therefore we calculate the algebraic sum of that currents, that means the I1 plus I2. Okay, it does not equal to 0. If it does not equal to 0 means the sum of that short circuit currents are obtained. Okay, that currents is flowing through this restraining coil. Okay, that obtained short circuit currents are flowing through this restraining coil. Okay, therefore that currents flowing through this restraining coil, in that restraining coil we are having the currents internally. Okay, while comparing that currents to that short circuit currents, if the short circuit currents is greater than that restraining currents that will be produced in that restraining coils, in that case only the currents flowing through this operating coil. While flowing through these currents to that operating coil, in that case the coils are energetic. Okay, in that case only the coils are energetic. If that coils are energetic, then automatically due to the energetic of that relay coils, that gives the indication to that circuit breaker, and then circuit breaker disconnected from the generators and the transformers from that supply. Okay, both the generators and the transformers are disconnected from the supply lines. Okay, this type of protection is suitable in the case of a high voltage transmission lines only. Okay, why? Because we are using the high voltage transmission lines means low voltage transmission lines, some less faults are obtained. Due to that less faults, the windings does not be damaged in the case of a generators and the transformers also. Okay, for that reason only we are using the high voltage transmission systems. We are using the both combined protection for that generators and the transformers also. Okay, this is the one of the basic connection diagram for that generator and the transformers. Okay, in that generators is directly step up transformers. In this protection scheme, no circuit breakers is interposed in between the generators and the transformers. Okay, in the diagram we does not use any circuit breakers in between these generators and the transformers. Okay, the main advantage of such protection is that it simplifies the protection, and mainly the directional protection for both generators and transformers can be combined together by employing the CTs on neutral side of the generators on the HV side of the power transformer. Okay, normal protection lo మనం ఏం చేస్తాం, టూ సైడ్ జనరేటర్ కి ఒక సర్క్యూట్ బ్రేకర్స్, మళ్ళీ అలాగే ట్రాన్స్ఫార్మర్ కి, అలాగే డిఫరెంట్ టైప్స్ ఆఫ్ ప్రొటెక్షన్స్ కి డిఫరెంట్ టైప్స్ ఆఫ్ ప్రొటెక్టివ్ రిలేస్ ని వాటన్నిటిని యూజ్ చేసుకుంటాము. అలా నెంబర్ ఆఫ్ ప్రొటెక్టివ్ రిలేస్ అనేవి మనం ఇంక్రీజ్ చేసుకుంటూ వెళ్ళేసరికి ఏమవుతుంది, మనకి జనరేటర్ కాస్ట్ అనేది కూడా ఎక్కువ అయిపోతుంది. ఓకే, బికాస్ ఆఫ్ ద అకరెన్స్ ఆఫ్ ద మ్యాగ్నటైజింగ్ ఇంట్రెస్ట్ కరెంట్స్. ఓకే, డ్యూ టు దట్ interest currents. Okay, why the interest currents are produced? that will be developed in the case of a transformers. Okay, due to that faulted currents is flowing through that transformer winding. Okay, that all will be discussed in the transformer protection also. Okay, due to that interest currents, the transients, the relay settings in this protection scheme must be considerably higher than for the protections of that generators. Okay, మనకి ఆ ఇంట్రెస్ట్ కరెంట్స్ వల్ల ఏమవుతుందమ్మా, వైండింగ్ అనేది మనకి డ్యామేజ్ అయ్యే ఛాన్స్ ఉంటుంది కాబట్టి కంపల్సరీ మన సపరేట్ గా ప్రొటెక్షన్ అనేది తీసుకోవాలి. కాబట్టి ఇక్కడ మనం డిఫరెన్షియల్ ప్రొటెక్షన్ స్కీమ్ అనేది ట్రాన్స్ఫార్మర్ కి జనరేటర్ కి రెండింటికి మనం కన్స్ట్రక్ట్ చేసుకుంటున్నాం, ఒకటే ప్రొటెక్షన్ స్కీమ్ అనేది తీసుకుంటున్నాం. ఓకే, అలా తీసుకోవడం వల్ల phase shifting within the power transformer and the connection of that cities if a unit transformer is tapped off at the generator terminals. Okay, generator ki transformer ki okate manam tappings ద్వారా connect చేసుకుంటున్నాము. This also has to be taken care by a suitable connection of that cities. Okay, two sides మనం ఏం చేసాం, సిటీస్ అనేవి కనెక్ట్ చేసాము. ఆ సిటీస్ కి న్యూట్రల్ ఎండ్ దగ్గర ఒక ఎర్త్ రెసిస్టర్ అనేది అలారం సిగ్నల్ ఇచ్చేటట్టు ఒక రిలే కాయిల్ అనేది కనెక్ట్ చేసాము. ఆ రిలే కాయిల్ యొక్క మెయిన్ పర్పస్ ఏంటి, ఏమైనా ఎర్త్ ఫాల్స్ వచ్చినప్పుడు ఆ రిలే కాయిల్ అనేది ఆపరేటర్ కనెక్ట్ చేసుకుంటాం. ఓకే, ద ప్రైమరీ ఆఫ్ దట్ మెయిన్ ట్రాన్స్ఫార్మర్ అండ్ అన్బ్యాలెన్సెస్ ఆర్ అప్టైన్ ఇన్ దట్ బోత్ ద సిటీస్. ఇన్ దట్ కేస్ ఓన్లీ ద డిఫరెన్షియల్ రిలే విల్ బి ఆపరేటెడ్. ఏమన్నా మనకి అన్బ్యాలెన్సెస్ కరెంట్స్ అనేవి బోత్ ద సిటీస్ లో, సిటీ 1 లో సిటీ 2 లో కానీ ఏమన్నా అన్బ్యాలెన్స్డ్ కండిషన్స్ అనేవి అప్టైన్ అయినప్పుడు మాత్రమే మనకి ఆ రిలే కాయిల్ లోకి ఆ కరెంట్ అనేది పాస్ అవుతుంది. ఓకే, నార్మల్ ఆపరేటింగ్ కండిషన్స్ లో ఆ రిలే కాయిల్ లోకి మనకి కరెంట్ అనేది పాస్ అవ్వదు. అంటే ఏంటి, ఏదైనా సిటీస్ లో బ్యాలెన్స్ అనేది డిస్టర్బ్ అయినప్పుడు మాత్రమే. ఓకే, అలా బ్యాలెన్సెస్ డిస్టర్బెన్స్ అవ్వకుండా మనం ఏం చేస్తున్నాం, రెసిస్టెన్స్ అనేది కనెక్ట్ చేసుకుంటాము. ఆ రెసిస్టెన్స్ ద్వారా ఫాల్టెడ్ కండిషన్స్ లేనప్పుడు మనకి బ్యాలెన్స్ డిస్టర్బెన్స్ అవ్వకుండా ఆ రెసిస్టర్స్ అనేది మనకి లిమిట్ చేస్తుంది. ఓకే, దట్ ఈస్ ద మెయిన్ యూసేజ్ ఆఫ్ దట్ combined effect of that generators and that transformers. Okay, this will be used in the case of the HV winding only. In the HV side we are using this type of combined protection for that generators and the transformer units. Okay, the stator winding of the generator and the LV winding are the primary winding of the main transformer and unit transformer comprise a separate circuit having no electrical connection. Okay, there is no any electrical connection between these transformers and the generator units. Okay, so an earth falls at any point of this uptime, that earth falls are not detected that earth falls are detected from that restricted earth fault protection. Okay, why? Because we are using this restricted earth fault protection means that in that why? Because we are using this restricted earth fault connection means that in that primary and the secondary winding there is no electrical connection between these two windings. Okay, that's why there is if any earth faults are obtained in that stator winding, that earth faults does not detected for that differential protection scheme. Okay, that's why in the case of that secondary winding of that transformer we are connecting the one restricted earth fault relay. Okay, కాబట్టి మనం ఏం చేస్తాం, ఒక రిస్ట్రిక్టెడ్ ఎర్త్ ఫాల్ట్ రిలే అనేది కనెక్ట్ చేసుకొని ఏమైనా ఎర్త్ ఫాల్ట్స్ అనేవి సెకండరీ సైడ్ అప్టైండ్ అయితే ఈ రిలే అనేది ఆపరేటర్ టు సెట్ చేసుకుంటున్నాం. ఎందుకు మనకి ఇక్కడ సపరేట్ గా సెకండరీ సైడ్ ఒక రిస్ట్రిక్టెడ్ ఎర్త్ ఫాల్ట్ రిలేని కనెక్ట్ చేసాము అంటే మనకి ఎటువంటి ప్రైమరీలో సెకండరీ నుంచి ఎటువంటి ఎలక్ట్రికల్ కనెక్షన్ అనేది లేదమ్మా. మనకి ట్రాన్స్ఫార్మర్ మీకు తెలుసు కదా, ఆల్రెడీ ట్రాన్స్ఫార్మర్ లో ప్రైమరీకి సెకండరీకి మనకి కనెక్షన్ అనేది ఉండదు. కాబట్టి ఎక్స్ట్రాగా రిస్ట్రిక్టెడ్ ఎర్త్ ఫాల్ట్ ప్రొటెక్షన్ అనేది సెకండరీ సైడ్ ఇచ్చాము. మిగతా అన్ని ఫాల్ట్స్ ని డిటెక్ట్ చేయడానికి డిఫరెన్షియల్ రిలే ప్రొటెక్షన్ అనేది యూస్ చేసుకున్నాము. ఓకే, దిస్ ఇస్ ద మెయిన్ సర్క్యూట్ డయాగ్రామ్ ఫర్ దట్ జనరేటర్ అండ్ ద ట్రాన్స్ఫార్మర్ యూనిట్ ప్రొటెక్షన్. ఓకే, అర్థమైందమ్మా?
ఎస్ మేడం.
ఇంకా అయిపోయిందమ్మా యూనిట్ 3rd యూనిట్ కంప్లీట్ అయింది. ఓకే, మీకు ఇంకా ఏమైనా డౌట్స్ ఉంటే ఒకసారి చూసుకోండి, వీడియోస్ అన్ని అప్లోడ్ చేస్తున్నాయి కదా, ఒకసారి చెక్ చేసుకోండి. ఓకే
ఓకే మ్యామ్.
మామూలుగా అయితే మన జనరేటర్ కి వేరేగా, ట్రాన్స్ఫార్మర్ కి వేరేగా ప్రొటెక్షన్ ఇచ్చాం కదా, దానికి కాస్ట్ అనేది